And this is the fastest man-made object, faster than the speed of sound and about 0.064% of the speed of light. I am talking about the Parker Solar Probe.
10, 9,
9,
Fisher start.
8, 7, 6, 5, 4, 3, 2, 1, 0. Liftoff of the mighty Delta IV Heavy rocket with NASA's Parker Solar Probe, a daring mission to shed light on the mysteries of our closest star, the Sun.
Sun is a massive star present at the center of our solar system, and it is by far the closest and the only star to support life. Of course, there are many other theories that say that there are many other stars that would be supporting life, but these stars would be present in other galaxies which are many light years away from us. And Sun is the only star which is the closest to us. So to get to know about the mysteries of the stars supporting life, we need to get to know about the Sun first. The idea of sending a spacecraft to the Sun was proposed in 1958, but there were no such technologies till the 2000s. In 2018, NASA was successful in sending its first aircraft to the Sun. But what is the need of all this? To understand this, we need to get closer to the Sun, close enough to know that there is no actual surface of the Sun. The Sun is composed of layers. The inner layers include the core, radiative zone, and the convection zone, and the outer layers that are about 432,000 miles away from the core include photosphere, chromosphere, and a small transition area, and the outer corona. Photosphere is the deepest layer of the Sun that is visible to us, whereas corona is the outermost layer of the Sun, which actually consists of hot flares of plasma and is only visible at the time of solar eclipse. Now there is something mysterious about these layers. Photosphere is actually not that hot. The highest temperature is about 6600 kelvins, but the temperature starts to increase from 8000 Kelvin to about 500,000 Kelvin in the transition layer as one goes towards the outer layers. And no one has an explanation that why is this actually happening. Not just this, in the corona there are many solar particles which are bound to the Sun with the gravitational pull and the magnetic field of the Sun. Yet some solar particles escape from this pull of the Sun and move in high speeds in the whole solar system. This is known as solar wind, and it tends to destroy all the man-made objects and the satellites in the solar system. No one actually has an idea that from where these particles are originating and what is the reason of such high speeds of such particles. Sending an aircraft to the Sun could be a potential answer to all such questions. Now this aircraft is the Parker Solar Probe, which is named after Dr. Parker, who is actually a professor at the University of Chicago. And this man mathematically gave the theory of the solar winds for the very first time. In April 2021, this probe crossed the corona layer for the very first time in history, and this happened during its 8th orbit around the Sun. Now I have a genuine question. This probe got so close to the Sun and it was not destroyed. What is so special about this? The answer is based upon how it is built. The white shield which you see here, it is basically made up of carbon-carbon, which is something like graphite epoxy. And on the inside, it is made up of carbon foam, which acts as a reflector of heat. This can withstand a temperature of about 2500 degrees Fahrenheit. Also, there is a cooling system within the probe that actually works by circulating water from the solar cells to the radiator from where it cools, which helps to keep the solar cells cool. The Parker Solar Probe is majorly made up of 4 instruments. The first instrument is ESIS. This is basically for the solar energetic particles present around the Sun. Their types, the types of gases present in them, their paths, and how are these paths disrupted. This is the first light data of low energy particles that tells about their energies. And here is another graph that shows the first light data of higher energy particles that also shows the energy of hydrogen and helium. The second instrument is fields that actually measures the electric and magnetic field around the Sun. The third instrument is WISPER, which is actually the camera for the probe. And the last, fourth one, is SWEEP, that actually examines the solar wind and the coronal plasma. and actually finds that what type of particles are there in the solar winds, including electron, proton, and helium ions. This helps in understanding the velocity, density, and the temperature of the solar winds. This is some early data from SWEEP in which the red strokes show the solar wind. So, this solar probe is in our solar system since 2018. And of course, there are a number of findings and we have to talk about them. This is the first aircraft to cross the boundary of the sun for the very first time. This boundary was not even defined earlier, and now we have these uneven pictures of the boundary. This boundary is basically the Alfvén critical surface. Scientists earlier gave the theory that the area around the sun should not have any dust particles. And this probe gave the very first evidence of this theory by these cool pictures. During the sixth circle around the sun, the Parker Solar Probe found that the magnetic field around the sun is actually non-uniform. This arises due to the giant hot plasma bubbles in the sun that spread, then cool, and then sink back, forming the magnetic funnels in our solar system. And this might be powering those solar winds. And there might be many more things yet to be discovered. There is something else to learn from this also. Some journeys might seem to be really hard or might be really hard, but the way of getting to new destinations is just by making those journeys happen.
When you have a space mission into an unknown place, you find remarkable things that you did not anticipate.
So, this was all about this video. Do let me know how do you feel about the same. And also, if you are an expert in this field and have some additional information about the same, do let me know in the comments. Thanks for watching. We'll meet you in the next video with another optimistic science and tech story. Till then, bye-bye.